So everybody, we're now on page 2 of our notes for 8.1, right triangle trigonometry. The main ideas behind the problems that we're about to face, these are going to be applications of the right triangle trigonometry. What we're going to be looking at are two different things. First one is going to be what we call the angle of elevation. Angle of elevation is going to be the line of sight from a fixed object, namely in this case we're looking at from this dude's eye. And then the angle that opens up to the object is called the angle of elevation. And then secondary, if you have something looking down, what you do is you draw a straight line to the horizontal, parallel to the ground, and then you have an angle of depression which opens down. So for the next series of problems we're going to be working with, we're going to use these as kind of like a basis of thought. And so let's go ahead and jump into problem number 2. You're standing 45 feet from the base of a 150-foot cliff. What I always like to do is I always like to draw a picture. There is a cliff, and we are told that that cliff is 150 feet. And we are standing 45 feet from the base. Now, all these triangles that we are going to be drawing in terms of like real-life situations, these triangles don't necessarily have to be drawn to scale. But the closer that you draw these to scale, we're going to be able to see those relationships a little bit better. So 45 feet from the base of a 150-foot cliff, and the line of sight from your eyes is 5.5 feet. So this one might not be best drawn to scale if we draw a little guy in here, and we know that this is 5.5. That's okay. Question A, what is the angle of elevation from your feet to the top of the cliff? Let's go ahead and draw that in, and there's our triangle. The angle of elevation is what we're trying to find there. That is our theta. What trig function do we know represents theta? 150 and 45, and the answer to that should very quickly be the tangent of theta is 150 over 45, which means theta is going to be the inverse tangent of 150 over 45, and the inverse tangent of 150 over 45 is approximately 73.301 degrees. We go ahead and change color, so we have part B, which is going to be something different. That part B is, what is the angle of elevation from your eyes to the top of the cliff? So that's why we are told that this person is 5.5 feet above the ground. We are now trying to find that theta. So in this case, we are no longer looking at a 150-foot cliff. We are going to be looking at this distance here, which is 150 minus 5.5, so 149.5. And now, once again, we could say the tangent of theta is 149.5 over 45 because we haven't moved any closer to the cliff. So theta is now the inverse tangent of 149.5 over 45, which that inverse tangent is going to be about 72.702 degrees. And the question I always ask myself is, does it make sense that the angle that we get is what it is? And what frame of reference do we have? We know that from the ground it's slightly bigger than from our eyes. That makes sense to me because it's not going to be quite as big of an angle from there. Now let us go ahead and take a look at our next problem. A woman standing on a hill sees a flagpole she knows is 60 feet tall. The angle of depression to the bottom of the pole is 14 degrees. The angle of elevation to the top of the pole is 18 degrees. So I know that, let's see, we have a woman standing on a hill. So from her viewpoint, let's go ahead and draw her in. So let's give her some arms. Those arms are a little low on her body, but whatever. We know that we have an angle of depression. So once again, I'm going to draw a horizontal to the ground that looks at this flagpole. This flagpole is going to be situated right here. And we know that the angle of depression to the bottom of the flagpole is going to be 14 degrees. And then we have the angle of elevation to the top of the pole. Let me go ahead and change colors so I can represent this situation differently. The angle of elevation to the top of the pole is 18 degrees. Our goal is to find the distance from the pole, and I should have made sure I said that I know that this overall distance is going to be 60 feet tall. So what's our distance from the pole? Looking at this, redrawing this, my goal is to figure out what x is. Well, how should I do this? What trig function do I know represents this entire situation? And I will say Nothing. We don't know anything specifically because if we use this entire angle, we no longer have a right triangle, therefore we cannot use it. So we're going to have to break this up into triangle by triangle. So let me start with the red triangle since I'm already using the color red. I will say, what relationship do I know? I know I have 18 degrees and I have x right here. That's what I'm trying to find. And I know 60 is the entire flagpole height, but I don't know just this portion of the flagpole. So I'm going to generically call that y. And I'm going to set up a system of equations. So I will say the tangent of 18 degrees is y over x. And I could do something similarly with the blue triangle. I will have the tangent of 14 degrees is, well, what is this distance? If the top part's y, then this is going to be 60 minus y. So 60 minus y also over x. And this is where I could set up my system of equations. We could either put everything in terms of x or put it in terms of y, whichever approach we really want. So let me go ahead and say I know that x times the tangent of 14 degrees will equal 60 minus y. In red, I also know that x times the tangent of 18 degrees is y. I think I'm just going to go ahead and substitute this in place of y down here and get everything in terms of x. So, with that in mind, I will take x tangent of 14 degrees equals 60 minus x tangent of 18 degrees. And then bring both x's to the same side. X tangent of 14 minus or plus x tangent of 18 will equal 60. And I don't know if you remember what we did in chapter 5 when we were solving some problems. We will say that let's factor our x out, and we're left with the tangent of 14 plus the tangent of 18 equals 60. So x is going to be 60 divided by the tangent of 14 plus the tangent of 18. Well, what is 60 divided by the tangent of 14 plus the tangent of 18? That is approximately, if you plug it into the calculator, 104.485 feet. Let me go ahead and write that a little bit more clearly, 104.485 feet. And you guys are pretty much used to me drawing off the page all the time. So I am sorry about that. Problem number 4, something very, very similar to this. That to measure the height of a cloud cover at an airport, a worker shines a spotlight upward. So we have cloud cover. Let's go ahead and draw on some cloud cover. So we have a worker shining the spotlight upward. So where's my ground? My ground, let's make right here. If the spotlight's right here, that angle of elevation is going to be 75 degrees. We have an observer who is 600 meters away, measuring, so 600 meters away, measuring the angle of elevation to this spot of light. Let's kind of highlight that in gold. So we have the angle of elevation to that spot, 600 meters away, and that is a 45-degree angle of elevation. Our goal is to find the height of the cloud cover. So we could do something similar to what we did before. We could set up 2 triangles. We could have this triangle or this triangle. Let's start with the red triangle. Let's call that x. And then this one would be 600 minus x. So this time, what relationship do I have between the 3 pieces of information? 75, x, and h. That would once again be the tangent. So tangent 75 is h over x. And then in the other situation, let me go ahead and make that one blue. We would have the tangent of 45 would equal h over 600 minus x. And solving just like we did before, h is x tangent of 75, h is 600 minus x tangent of 45. And now I have 2 options in front of me. Do I want to put this in terms of h, or do I want to put this in terms of x? My thought is, my goal is to find h, which is right here. In order for me to find h, I would like to solve it for h, which means get everything in terms of h. So I will solve x, which is h over the tangent of 75, and that's what I'm going to substitute in the other equation. H then will equal 600 minus h over the tangent of 75 times the tangent of 45. And like before, I'm going to solve it for h. First, I need to distribute, so that would be 600 tangent of 45 minus h times tangent of 45 over the tangent of 75. So bringing the h to the other side and then factoring it out, let me go ahead and do that 2 steps. H plus h tangent 45 over tangent of 75. This will equal 600 tangent of 45. Scroll over just a little bit. And once again, not much room. Factoring out that h, I will get h times 1 plus tangent of 45 over tangent of 75 would equal 600 tangent of 45. So h, hate to write in the box, but that's okay. H will equal 600 tangent of 45 over 1 plus tangent of 45 over tangent of 75. Now in a calculator, that should approximately be 473.205. And now we are going to be at the section that's going to be with us for the rest of the chapter 8. And it even goes into chapter 9 as we're dealing with vectors. We are going to be talking about something called bearing. Now, physics does bearing a certain way. I know that in many applications of real life in terms of working with airplanes, bearing is done on a 0 to 360 scale. What we are going to see in our book and our problems, we are going to see a north-south, so north-south, then we're going to have a degree followed by an east or a west. So we all know that east is over here, west is over here. Never eat soggy waffles. I'm sure some of you have heard that before. So in terms of bearings, when we see it written in this format, this is 42 degrees east of north, so 12 degrees west of south. As we look at our first series of problems, we want to know the bearing from the origin to all of our individual points. So we're going to start off with point number 1. So when I look at this angle right here, I'm going to start by saying this is north, and then this is 30 degrees to the east of north. So we write that as n 30 degrees east. Point 2, similarly, we look at point 2 and say, all right, here's my point 2. Here's my south, and so we'll start by going south, and then how many degrees west of south? That would be 50 degrees. Point 3, similarly, could be written as we go to the north, so 70 degrees west of north, followed by point 4, which is to the south, and then how many degrees? 20 degrees east. And I do believe that we can write this in many different ways, but we're going to stick with this notation, especially as we're doing our virtual learning. So a plane takes off on a runway that has a bearing of 20 degrees east of south. I always like to draw my origin. So if I go 20 degrees east of south, that would be an angle like so, so 20 degrees. After flying for 2 miles, the plane turns 90 degrees to the southwest. So here's my 90-degree angle. Travels for another 5 miles. What's the current bearing and how far away is it? Current bearing is going to be this angle right here. Let me do that one in blue. So that theta is going to be my bearing, and I want to know what x is. X is going to be the square root of 2 squared plus 25 squared, or the square root of 29 miles. That would be 5.385 miles. And then to find our angle, our theta is going to be the inverse tangent of 5 over 2. And that inverse tangent is 68.199 degrees. But keep in mind that covers this entire distance. So we have to subtract the 20 degrees that it is. And we get our bearing of south, 48.199 to the west.